Let's discuss a problem from GATE 2021 Physics. So this is related to finding the electric field amplitude of electromagnetic wave. So the problem is an electromagnetic wave having electric field E is equals to 8 cos kz minus omega t y cap volt per centimeter is incident at 90 degrees normal incidence on a square slab from vacuum with refractive index n naught equals to 1. So here we can see, so this is the electromagnetic wave incident at exactly 90 degrees. So normal incident at 90 degrees to the normal on a square slab from vacuum with refractive index. So here the refractive index is 1.0. So it is incident normally. In this manner it is being incident. So now the slab is composed of two different materials with refractive indices n1 and n2. So here you can see two different materials, also two different colors. So this square slab is made up of these two materials. So assume that the permeability of each medium is the same. So yeah, permeability means mu for this medium, permeability mu2, for this medium permeability mu1, but they are saying us to assume it to be the same permeability, so we need to just neglect about this permeability. After passing through the slab for the first time, the electric field amplitude in volt per centimeter of the electromagnetic wave which emerges from the slab in region 2 is closest to. So here what we are supposed to find is, we need to find electric field amplitude in volt per centimeter of the electromagnetic wave which is emerging from the slab in region 2. So in this region, the electric field amplitude we need to find for the electromagnetic wave which is getting emerged from the slab. So it will fall and finally like this it has to come. So that one, based on that we just need to discuss a few points. So these are the options. So according to the question, so this is the incident ray. So it is entering from n0 medium n where n0, that is refractive index, is 1 to the medium where refractive index is 2.2. So we need to first of all find out how much rays is being transmitted. That means how much intensity of light is getting transmitted. So because there could be some reflection or transmission also. So nobody is a perfect reflector, nobody is a perfect transmitter. So there would be some kind of reflection but and some kind of transmission. So reflected rays would go like this only, so like this. So rays are incident in normally, so in this manner they would just get reflected, but transmitted rays will enter into this medium at this, like this. So that is in straight manner, it is like this, in a straight manner. So from here to here, this, so like this it would be incident. So first of all we need to find out here how much is being get transmitted. So for that, so let I not be the intensity of incident light. So the light which is incident from here, its intensity is I naught, and I will be the intensity of transmitted light when light moves from n0 to n1. So when it moves from here to here, the light, so the transmission intensity is I1. So the formula for finding this I1 is nothing but incident intensity into transmission coefficient. That means transmission coefficient gives us the fraction of light that is being transmitted. So out of total light, how much fraction is being getting transmitted. So for transmission coefficient, the formula is this. So for n0 n1 plus n0 whole square. That means here the two mediums. So what are the two mediums here? This n0 and n1 first of all. So the light is coming from n0 medium n0 to medium n1. So that is refractive indices. So here for n0 n1 n1 plus n0 whole square, and for reflection coefficient the formula would be n0 minus n1 whole square by n0 plus n0 whole square, like that. So you would get this n0 minus n1 whole square, like that, for the reflection coefficient, and then denominator the same value. So if we add this both in the numerators, if we see n0 square plus n1 square minus 2 n0 n1, here 4 n0 n1 is there, they both get added up, we will get 2 n0 n1. So that is nothing but n0 plus n1 whole square. So that means transmission coefficient plus reflection coefficient must be equal to 1. So based on that condition, so we will get this reflection coefficient, but here we are not supposed to find the reflection coefficient, only transmission. The formula is this. Next, another important thing we need to see here is for light ray moving from n1 to n2. So after getting transmitted, this ray here you can see it is moving from n1 to n2. So now we need to see whether this is getting moved to this medium, that is refracted to this medium, or else it is returning to the same medium. That means total internal reflection is taking place or not, that one we need to see in this step. So for that we need to apply this Snell's law. So n1 sin I is equals to n2 sin r. So n1 into incident medium where the light is incident, sin I angle of incidence, and n2 sin r. So for the total internal reflection, that means at the critical angle. So if this is denser to, so it actually takes from denser to rarer medium. So here we can see the formula for refractive index is nothing but n is equals to c by v. So optically denser medium is 1 where velocity of light is less. So as the value of velocity decreases, n value increases because it is in the denominator, so n value gets increased. So more is the n value, lesser is the velocity of light, and optically denser is the medium. Optically denser medium means velocity of light is less. Here among 1.1 and 2.2, the higher value is 2.2. That means there the velocity of light is less. That means it is optical denser to medium. So for the total internal reflection, the light must go from denser to rarer medium. So that is the important condition. So here we can see it is. So at the critical angle, what happens is, so actually for particular angle of incidence, refraction would take place. At critical angle, it would be completely grace, that is angle of refraction is 90 degrees, and above this the ray would get total internal reflection. So this is the basic of total internal reflection. And at critical angle, theta is 90 degrees, angle of refraction 90 degrees. So sin 90 is 1, sin c we don't know, n2 by n1 is nothing but sin c, and we see here n2 has 1.1 and n1 has 2.2. So 1.1 divided by 2.2. So if we get make this, that means 11 by 22, that means 1 by 2. That means sin 30 is 1 by 2. Hence the value of c is 30 degrees. That is critical angle is 30 degrees. So at an angle greater than is, if the angle is greater than critical angle, if the angle of incidence is greater than this critical angle, what happens is total internal reflection takes place. Now coming to this diagram, we need to see here what is the angle of incidence. First of all, we need to draw a normal between the two surfaces. The normal would be this is the normal. From this we can see that this angle would be 45 degrees, this angle would be 45 degrees. So as it is incident in this manner, so it is just like cutting exactly half, that angle into exactly half. Here 45 degrees and here 45 degrees, and it would get, so if this 45 degrees is greater than 30 degrees, that means here total internal reflection takes place and the ray would go in this manner. Finally, this ray would go in this manner, like this. It would just go like this. So in this manner it would go, because angle of incidence is equals to angle of reflection based on the laws of reflection. So finally, here by this what we can say, so whichever rays is falling on this slab, so whichever rays are entering in this region, they would get total internal reflection. That means no ray would enter into this medium. So all of the rays would come to this medium only. By this we can say the ray which intensity of ray which is coming here in this side is same as the intensity of ray entering. So intensity of entering ray is same as this leaving rays. So here also we would have the same intensity, that is as per the question. So here we have mentioned in I2 is the intensity of transmitted light from N1 to N0. So next what is happening here is, after this the ray is going from N0 to N1. Here we can see N1 to N0. So this is N1 and this is N0. Now here we need to see what is happening to this ray. And as it goes from N0 to N, previously it was coming from N0 and it entered into N1. Now it is coming from N1 and it is coming out of into the entering into the N0 region. So reverse process is happening. So again we need to apply the same formula. So I2 be the intensity of transmitted light from N1 to N0. So it would be equal to I1 into T. I1 into transmission coefficient. I1 is nothing but how much light is coming here. So here how much light is coming? I1, just as here intensity of light coming is I1. So here also the same thing happens. And while coming outside, that is I2. After coming outside, that is I2. This one we needed to find out. So that was asked in the question, that is not intensity, of course amplitude. And for this formula is I1. So how much light is falling into transmission coefficient? So I1 into 4 N0 N1 N1 plus N0 whole square. And we know that I1 from here, from this formula, I0 into 4 N0 N1 divided by N1 plus N2 whole square. So if we substitute that I0 into, so already 4 N0 N1 is there, again another 4 N0 N1, so it would get squared. So finally this is the intensity of light coming out, and we know that intensity is nothing but proportional to amplitude square. So amplitude square means amplitude of electric field square. So the E2 square, the electric field, that is light which is coming outside from we were supposed to find out this only, this question, how much light is coming in this direction, that we are supposed to find amplitude of light, amplitude of electric field. So pausing through the electric field amplitude. So for this reason we are replacing this intensity with E2 square. E2 square is nothing but amplitude square, and I0 is replaced with E0 squared. And now if we take square root on both sides, that means both are squares. If the squares get cancelled, finally we would have this, and only thing we need to do is just substituting the values. These values were given in the question. E0 is 8. This was already given in the question. So here this is nothing but E0, amplitude of electric field which is falling, and N0 and N1 were also given, N0 1, N1 2.2. We just need to substitute all those values. 4 2.21, so 2.2 plus 1 is nothing but 3.2 whole square. So if 4s are 32, 2.2, 3.2 into 3.2. So here 3.2 tens are, finally what we will get is 22 by 3.2. 2 11s are 2 1.6 are. So finally we are having this 11 divided by 1.6. So this is the amplitude of electric field which is coming out of the region. uh, so the answer for this problem is 11 by 1.6. So this is the correct option. This is the problem. Thank you.